Alright guys, this is a short video walking you through how to draw a schematic and then read resistor values, and basically helping you to understand how to put together a circuit. So first thing you need to understand are the parts of a circuit. So let's look at the parts of our circuit we have here. So we have a battery for power, some wires to connect everything, a resistor, and an LED. Now in electronics we use special symbols to represent these components in a diagram called a schematic. So that's like a map for the circuit. So a battery symbol looks like two parallel lines, one long line and one short line. The longer line is the positive side and the shorter one is the negative side. That's called a voltage source. Sorry, that's kind of messy. You just go here. Okay. Then we have the wires. So the wires are these are going to connect everything, and this is the path for the electricity to follow through. The LED is for light emitting diode. So that's what it stands. What it really means doesn't really matter at the moment. It's just like a light bulb. It produces light when you run electricity through it. And how we represent that is with a triangle with a line at the end of it. So again, that's a little messy, so I'll redo that, and you'll see here something like that. And there's also two arrows pointing away from it, so to just denote like that it's producing light. So this is actually called a load because it's what is consuming the power that's being produced by the battery. And the resistor here is shown as a zigzag line on a circuit. So we'll talk more about what this does in a minute, but its job basically is to resist the flow of electricity. So let's connect up the wires. So you try to do straight edged 90-degree lines on a circuit, so I'll do my best here. So just something like this, straight edge. So it's going to be a box, basically. That's the shape that you're going for. And we'll connect everything up. So that's the LED. This was the resistor. And we're drawing out the wires now, the path for the electricity. So this goes to the other side, the negative terminal, right? So it forms a circuit, a loop. So the next step is we have to choose a resistor for the circuit. So we know right now if we were to hook up this LED directly to this battery, it would instantly burn out because the LED can only handle a certain amount of power or current. So it can't handle the full current coming from the battery. So how do we make sure we don't send too much flow of electricity to the LED? That's why we need a resistor. So represented by this zigzag line. So the resistor's job is to resist or slow down the flow of current. And we need to choose one that has the right value. We can't just pick any resistor. We have to pick one that has a specific resistance. And to do that, we have to do a little bit of math using something called Ohm's law. And if you're familiar with Ohm's law, it's okay if you're not familiar, but it basically is just a relationship between voltage, current, and resistance to help you figure out how these are related. And what it says is that voltage is equal to current times resistance. And so voltage can be shortened as V for voltage is current, which can be shortened as I in this formula times resistance, which is R. So that's Ohm's law. Resistor, we need to rearrange the formula to solve for resistance. And a quick trick to do that is to just draw, for those of you not familiar with Ohm's law, you can just draw a triangle and draw the parameters of Ohm's law inside of it. So V, right, I, and R. And whichever one you want to solve for, that's the one you're going to cover up. So we want to solve for resistance, right? Because we want to know what value of resistor we should use to protect our circuit from burning out the LED. So we'll cover up R, and now what are we left with? V, volts, divided by the current I, right? If we wanted to solve for a voltage, we would cover up the I, and we would be left with the current times resistance. And so that's just something you could remember as a way to use Ohm's law when you're trying to figure out, predict how the different components of your circuit are going to behave and do calculations like these. So the next thing we need to know is that the LED consumes some of the voltage from the battery. So when the battery is is running and connected to the circuit, the LED is going to consume some of that power. It's actually going to consume 2 volts of the 9, right? So what we need to account for when we're doing this calculation to figure out what resistor we want, we need to not figure out for the entire 9 volts, just the remaining 7 volts that are coming through after the LED lights up, because it actually needs that 2 volts to produce light, right? And that's that value comes from the data sheet from the company that sells the LED or the kit. You can Google that or look it up and you'll see what that value, specific value is. The other value you'll find in that data sheet is the maximum current that the resistor, that the LED will be able to handle. And the maximum current that this LED can handle is 20 milliamps. So with that number, 20 milliamps, we're going to play it safe and only use half of that. So we're going to use 10 milliamps, right? So now we have 2 numbers in play, new numbers. The 10 milliamps that the manufacturer said was the max current this LED can handle from its data sheet. And we know that our current is, the power, total power is 9, but we're going to take off 2 for the LED, using that to light up. So we're only going to need to account for 7 volts, 7 volts, and 10 milliamps. Now 10 milliamps, what you need to know about milliamps is that 1,000 milliamps is 1 amp, right? So when we do this conversion into amps, which we need to do to use the formula, we'll see that we only have 0.01 amps. So this is what we're working with, and once we do this math here, we'll see that this is actually 700 ohms. That's the resistor that we need to find to protect this circuit. And that it's symbolized with an omega symbol. You'll see that if you're working with electronics, you'll see this omega symbol. Often it's a Greek symbol for resistance. So the thing is about 700 is that the kit or the company that you're going to buy these parts from, they won't have that value. That's not a typical resistance value. They'll only have certain resistor availables, and they come in like different values. So there'll be like 220 ohm resistors, 330, 1000, 2200 ohm resistors. They won't have 700. So what we're going to do is we're going to choose 1000 ohm resistor because that is a more typical value you would find from a vendor of electronics or a kit, right? And that's also higher than our value, which means it'll be even more safe for our LED. So choosing that 1000 ohm resistor, now we have found what we're going to use. So we're in good shape. But we can even go further than that. We can say, okay, now that we've chosen that, what effect is that going to have on the behavior of the circuit? Is it going to go faster? Is the current going to be higher than 10 milliamps, or is it going to be lower than 10 milliamps? And you can pause the video here and try to just make an educated guess. If we add a higher resistance, will there be a higher current in the circuit or a lower current than 10 milliamps? So going here back to our Ohm's law, you see that if we were to increase the resistance, what would happen is the actual current would go down. And to prove that to you, we can just work it out with the math. So how do we know what to do? Well, we say we're actually interested in current this time. So to do that, we need to have the volts, which we know from before, it's 7, and the resistance, which we have now, which is 1000, or ohms, and this is going to be the current. Now when you work this out, what you're going to find is that this is 7 amps. 7 amps. Or, I'm sorry, 7 milliamps. So it actually runs to 7 amps. 0.007 amps, but that's 7 milliamps, right? Now, that number is smaller. Why? Because we chose a higher resistor value. And so that's expected because voltage and resistance have an inverse relationship. So anyway, the circuit is even more safe now because we're adding more protection for the LED. And so that's all. That's all you need to know to work out the value of a resistor that you need to use on a circuit, and to be able to choose the right one to make sure you're not burning out your LEDs. Alright guys, now for the fun part. So we've talked about the concepts behind the circuit, and we've drawn a schematic of our circuit, and we've even calculated the resistor. So now it's time to actually build a circuit in real life, and to do that we're going to use something called a breadboard. Now bear with me guys, I know people are very familiar, but others are not so much. This might be their first time. So how a breadboard works is that the top 2 rows and the bottom 2 rows of a breadboard are physically connected side by side. So if I were to connect the wire to this hole and this hole, those two would be connected. The electricity would flow side by side. If I connected a different wire, let's say I had one wire here and one wire there on the, you see where there's the blue line, those would not be connected. Electricity would not flow vertically. It would only flow if they were 2 wires were connected side by side. Okay, so that's important. When you connect a wire here, electricity is going to flow side by side, And when you connect a wire to this row, it would only flow side by side. It's not going to be sharing vertically. The same is true with the bottom two rows. The very bottom two have the same appearance. That's different from the main board of a breadboard. You can see there's more holes, and in this, it's the opposite. The vertical holes share electricity. They will share a connection. So if I connected a wire here at 1J and another wire at 1I in this hole, they would share electricity vertically. They would not share it with a connection if I placed another connection here in this hole or this hole. If I had a wire in 1J and I put another one in this hole, which would be 2J, they would not share connection side by side. Okay, that's not how the main board works. The main board works where when you connect the wire here and here, they will share connection. So they only share connection vertically. Okay, so let's move on. So what do you need when you start any circuit is a power source, right? So what's our power source? It's a 9-volt battery, right? And what we're going to use is something you may have never used before, which is called a battery snap. And I'll put the link for this in the comments. So a battery snap looks like this, right? And it has two cables coming from it. It has a red wire, and that's going to be the positive terminal of the battery. It's going to attach to the positive terminal of the battery. And the negative is going to be the black wire. This is going to attach to the negative terminal of the battery. So we're just going to snap this onto the battery. Right? And we're going to plug that black wire into our breadboard. Where are we going to plug it in? We're going to plug it into the blue rail here. You can see there's a blue marking. We're going to plug that black wire from the negative terminal of the battery to that blue rail on the breadboard. This blue rail is now our ground rail. Now, what does that mean? That ground rail is actually where the voltage is 0. It's our reference point for our circuit, where all the energy of the circuit is going to eventually return back to this ground rail. Anything that's connected to this ground rail, all the energy of the circuit is going to loop back here and return. Okay? So that's what the ground rail is, or the ground in this breadboard. Okay, so now let's go on to the next part. It's going to be the resistor. Now, if you remember, what does a resistor do? Remember that the resistor is protecting the circuit, or to protect the LED specifically, right? So we know from before, because we already did the work of calculating this, is that this is a 1000 ohm resistor, but you can look it up on a chart based on its coloring, okay? And what you need to do is bend its legs so that it kind of forms like this U shape, right? And then plug it in basically anywhere on the breadboard that's sort of nearby comfortably, and that the two legs are not in the same column. The two legs should not be in the same column, okay? So, a little tricky to do while you're recording, but let's see. Okay. All right, there you go. So you can see that the two legs are in different columns of the breadboard. So now what we're going to do is grab the LED. So if you remember about the LED, you might not be familiar, is that the LED has two legs, and also like the resistor does, but it has one longer leg. Yours might look slightly different, but I've been messing around with this one a little bit, so these are already bent up. Yours might be parallel and straight because they're new. But you bend them up so that they're separate from each other, right? So it's easier to manipulate and plug them into different holes. And what you're going to do is plug the longer leg, which is the positive leg of the LED, into one of the legs of the resistor. We're going to choose the right leg of the resistor. So let's do that. Let's plug it into the right leg of the resistor, our long leg of the LED into the right leg of the resistor. Okay? So you should be able to see that now the right leg of the resistor and the long leg of the LED are sharing a column on the main breadboard. Okay. Okay. So now what we're going to do is add a black wire to connect to the ground. So we're going to plug the short end of the LED, the short leg, into our ground rail. So we got this short end of the LED, which is just basically the other leg, and we're going to go into the ground rail. Remember, we set up that ground rail in the beginning, so we're just going to go right up here. Okay. So now we're almost at the finish line. One thing I want to add is a little bit of an extra, an optional, is another red wire, another wire to sort of clean it up so that we're not stretching the resistor. So I want to add actually a red wire to go into this red rail here. And now I'm going into the top again. I'm not in the main board. I'm in these top two rows, which behave differently. Remember, they share currents side by side. So I'm going to put this red jumper wire here, right, and the other end here. Now what does that do? Now the current, if I attach anything to this red rail, right, if I attach anything to this red rail, it's going to flow through this red wire and into my resistor. Now what would I attach to this red rail? Well, there's only one thing I haven't attached, and that's the battery, the positive terminal of the battery, right? The red wire. I've only attached the black wire. So what's going to happen when we connect the battery? Well, when we connect the battery, the electricity is going to flow out through the positive side, the red wire of the battery. So I haven't attached it. It's here, right? It's going to connect to this power rail. I'm going to create a power rail when I attach it into this hole, and the electricity is going to flow out the positive side of the battery through this jumper cable into the resistor leg, through the other leg of the resistor. So it's going to slow it down, and then it's going to get into the LED, light up that LED, go in to our black jumper cable and to the ground. Okay, so let's connect our battery. All right, there you have it. So our LED lights up perfectly. We've gone from a diagram to a working circuit. I hope you guys enjoyed that and you were able to learn something new, or if not, get some ideas for what you might do in your own projects. Thank you guys for watching.